Hello everyone and welcome to the video solution of the class activity Banking Deserts. In this activity, the broad task is to answer the question, what is the relationship between poverty, age, and population with the number of banks in a given area? To help accomplish this task, we've been given census data for every zip code across the country. The immediate task is to randomly sample at a set of 700 plus zip codes and then utilize both the Google Geocoder and Radar's API to identify the number of banks in each of these zip codes within a 5-mile radius of a given point. Once you have the bank counts, you'll then create a series of scatterplots comparing each of the following two bank count: population, median age, household income, per capita income, and poverty rate. So before we get started, let's take a look at our CSV. So here we have our CSV with our column zip code, address, population, median age, household income, per capita income, and poverty rate. So we'll be using every single one of these columns except address. Now, before we open up our Jupyter Notebook, I'm going to talk about how to hide your API key. So the way that's generally done is you create an external Python file. Here I've just called it config.py. There's a little comment about what is contained in the file and a variable with our keys stored as a string. Now, just bear in mind this key is no longer active, so you'll want to remember to put in your own API key when you're doing this activity. Okay, and it's just stored as a G key, so what we can do is we can import this variable from this file into our Jupyter Notebook, which is what I'm going to go ahead and do next. So we have our dependencies, NumPy to help us with the random selection, pandas for our data frame and our CSV, matplotlib for our scatterplots, and requests to get the data from Google. And in the end of that cell, you see right there, from config import G key. And this is how we hide the API key, because now no one knows what G key is except for us. So you take from the file name, import the variable, and you don't need to do .py because we're working in Python and it knows that that's a Python file because of the extension. Next up, I'm going to import the census data and preview it. Okay, so here we have the same columns: zip code, address, population, median age, household income, per capita income, and poverty rate. Next up, I'm going to randomly select 700 zip code locations that have at least 100 residents. So Pandas has a nice little function here called sample that randomly pick 700 rows from our data frame. And then we take selected zips, and then we take a look at only those rows where the population column has more than 100. And as you can see, for the first 5, they definitely have more than 100. Before we continue, you want to make sure that you start with a smaller set, because a lot of the times when you do API calls, the documentation will tell you that you can only do a limited number of pulls at a time. And so you want to make sure that you take a small sample of your 700, make sure your code runs perfectly for that, and then run it on the 700. Now I'm going to work on getting the latitude and longitude for each of these zip codes. And to do that, the first thing is to create blank columns in the data frame for the latitude and longitude. Next up, I'm going to set up the parameters for the API pull. And all that is to set G key to key for our parameters, and the parameters themselves will be a parameter in our request. Next up, I'm going to set up a counter. I'm now going to get started on our loop through our data frame. So we're going to be using iterrows. First thing we want to do in our loop is update the parameters with the zip code for each row. Here we are just adding another key value pair to our parameters dictionary, and the key is address and the value is the zip code. So for the first one, it's 17980. Next up, I'm going to create the base URL. Okay, so this is just going to be the base of our pulls to get the latitude and longitude, and then we will update it as need be for each zip code. Now I'm going to print a log to ensure that the loop is working correctly. Here I'm just printing now retrieving city number row count, and the way this works is we have a little f before the string starts, and that allows us to format the string. And so usually we would have to concatenate since row count is a number, but by using f and then putting our variable in curly brackets, we don't have to worry about formatting. And then we just add 1 to row count to keep the log updated. Next up, I'm going to run the request to grab the JSON at the requested URL. Here we are using our requests finally, and our parameters are our base URL and the params dictionary. So this will automatically add them together and make our request for us. Then we print the response URL just to make sure that we did get the correct one that we wanted. And then we stored the JSON variable into zip location to work with the data. Next up, I'm going to append the latitude longitude to the appropriate columns using try and accept to skip any cities with errors. So here we're using a try and accept, and what that does is it tries everything in here, and if a single line of code doesn't work out, it'll go to the accept and do what we want there. So what we're doing is we are taking our zip location, which is our request, and we're looking at the results, the geometry, the location, and then latitude, storing that one into latitude and doing the same for longitude. And then we're using loc to get the specific location of the latitude column and the current row index, and we're storing ziplat into it, and the same thing for the longitude. Now, if any of these don't work out, what's going to happen is we're going to have a print statement that says error with city data skipping. And so that'll print. And then we'll also drop the row from our selected zips data frame because we don't want to, have a city that doesn't have a latitude and longitude. Next up, I'm going to visualize the data frame and then run the cell. No worries if that took a really long time. You're running through 700 rows of data. So it should look a little something like this at the end with our updated selected zips data frame with our latitude and longitude columns. Next up, we're going to start on the bank count. The first thing we want to do for that is create an empty column. Next up, we're going to set up the parameters again. So this time we have 3 different parameters: radius of 8,000 meters from the latitude and longitude, the type as bank, and the key as our G key. Next up, I'm going to do a row count again. All right, we're going to get started on our loop. We're going to be using iteros again. The first thing we want to do in our loop is store the latitude and longitude as variables. Next up, we want to update the parameters. Okay, so here we're looking at our parameters dictionary. We're doing a new key value pair with locations as the key and the latitude longitude as the value. I'm just using formatting to convert them to strings. Next, I'm going to create the base URL. So it's a little bit of a different base URL from before. Here we're using the place API and we're using the radar search option of the place API, whereas before we were using the geocode option of the maps API. Next up, I'm going to print a log to ensure that the loop is working correctly. So very similar to the one before, we're just saying now retrieving city number and we're adding the address in. Next up, I'm going to run the request, print the URL, and convert to JSON. Almost exactly the same as before, we're just updating our variable names. So we have our base URL and our parameters, printing the URL to check that it's the one we want, and then converting it and storing the JSON variable. Next up, I'm going to measure the bank count on the number of results in the retrieved area. And the way we do that is we just take the length of the results. Next up, I'm going to print a final bank count for each area. Same formatting as before, final bank count, and then the bank count that we get. Next up, I'm going to store the bank count into the data frame. So we're using loc to get the specific cell where our index number is the current index and our column is bank count, and then we're storing bank count into that cell. Last but not least for the loop, I'm going to reset the bank account so there is no chance that a previous record is influencing a latter one. Finally, I'm going to visualize the data frame and then run the cell. Alright, no worries once again if there was a long wait time. Lots of data. So the final result should look a little something like this with our city, our URL, and the final bank count. Okay, and here's our updated data frame with our bank count column. Next up, I'm going to save the data frame as a CSV. So what I've done is I've saved the CSV to the output analysis folder and saved it as zip bank data. Pandas has a nice toCSV function where it makes it super easy to save our data frames. And then we just have index as false so that this column doesn't show up in our CSV. All right, let's go ahead and get started on plotting our scatter plots. The first one I'm going to do is population versus bank count. Okay, so here we're just using plot.scatter with our x values as our bank count column and our y values as our population column. And then the rest of these are just some aesthetic changes. We have the edge color of our marker as black, the width of that edge as 1 pixel, and the marker to make sure it's a circle, we just have it as O, and the opacity, which is alpha, as 0.8, and we just add a label as zip code. Next up, I'm going to incorporate some other graph properties. Okay, so just adding a title, x and y axes labels, and a grid. Next up, I'm going to save the figure. Matplotlib has a nice savefig function. We just specify our file path, which is into our output analysis folder, and then the name of our figure, population_bankcount.png. Finally, I'm going to show the plot. Here we have our population versus bank count plot. So sometimes, this isn't exactly what you want to view, right? You want it to be exact in terms of your x and y axis. And so the way we do that is we use plot.xlim or plot.ylim, and we specify the exact definitions of our x and y axes. So I'm going to go ahead and add a plot.xlim and a plot.ylim. So our plot doesn't look too different, but the markers are now closer to the edge, and you can really see the markers more in depth. And the reason I picked -2.5 to 202 for the x limits are that -2.5 allows us to see just a few of these markers that are still here, and 202 because the max bank count was 200. And then -2.5 to 110,000 is to, again, give us a little gap there and make sure that our limit doesn't go above, since our max y value was just above 100,000. Next up, I'm going to do the same, but for median age. All right, so here we have median age versus bank count. And we're going to keep the same x limit range for all 4 of the graphs because we know that bank count is not going to change across these. The ones we want to update are our y limits. And since our max median age was around maybe 72 or so, I made the y max as 80. Next up is household income versus bank count. Okay, so here we have our household income versus our bank count, and I picked 230,000 as the y limit, since our max is right about here, and this jumps up by 50,000 each time, so this is about 225,000. Next up, we have per capita income versus bank count. Here we go, same parameters, except that we now have 165,000 as our maximum y value, because you can see that one right there, 160,000. Last but not least, we have poverty rate versus bank count. Here we have our poverty rate versus our bank count, and once again, the difference is our y values, our labels, and our y limit. So this time we've done 102 since our poverty rate is a percentage, and we have the max around 90%. Let's take a look at our output analysis folder. So we have our 5 plot and our zip bank data. And as you can see, we have almost the same one as the one that popped up in the background as well, except we have some new columns: latitude, longitude, and bank count. We have our median age versus our bank count, our household income versus bank count, per capita income versus bank count, population versus bank count, and poverty rate versus bank count. And these were the same as the ones displayed here, so thankfully we didn't overwrite any of our images. And that is the video solution to banking deserts.